Most of us know that getting enough sleep is important for doing well in exams. University students who don't get enough sleep might not do as well in their exam because they are tired, not because they don't understand the material of what they have studied. And this project shows that students who get the right amount of sleep tend to have higher grades. Lack of sleep affects brain functions, including learning and attention. For example, if there is a positive link between sleep duration and math performance. As people age, they generally need less sleep. Babies sleep about 11 hours at night and nap during the day. Meanwhile, by age 18, the average sleep is around 8 hours. And some students suggest that recommendation about sleep might be more social opinions than evidence based. There is a criticism of studies where young people sleep as much as they want to see how much sleep they need. And some people are asking for clear guidelines on sleep, but they're never found the right way or the right time to sleep well. So this project focus on how lack of sleep affect academic performance or math performance, looking at both academic success and mental health. Optimal sleeps around 7 hours for top performing students might still harm mental health, and the hypothesis was that more sleep would correlate with better mental health, even if it didn't lead to higher academic achievement. And this project also considered that daily changes in sleep duration might give an impact on their education.
Assalamualaikum warahmatullahi wabarakatuh. Nama dia Betul Rashidi and I'm going to present about the objective of this project. And for the first one, our objective is to determine if there is a correlation between the number of hours of sleep students get per night and their mathematics test score. While the second one, our objective is to analyze the probability distribution of sleep hours among students and how it relates to their performance in mathematics tests. I'm going to present about the methodology. And as you can see, we have three methodology. The first one is random variable, and the formula is mu, which is represent as mean, and it's equal to expected value of x equal to sum of xi multiplied by probability of xi. And we also have the sigma 2, which is represent the variance of x equal to the expected value x squared minus the expected value squared. And the next one we have the estimation. For this formula we have the x bar plus minus the t alpha divided by 2 and comma b, which is represent the t critical, and we continue it with multiply by the s divided by n, which is s is the sample and n is the sample size. And for the last one we have the simple linear regression, which is y hat equal to beta naught plus beta 1x plus the epsilon, which is represent the error.
Hello everyone, I will present the result and discussion of our analysis on sleeping time. This table shows the data collected where we recorded the sleeping hours and their frequencies. The probabilities was calculated by dividing the frequency by the total data points. For example, 4 hours and 5 hours of sleep were the most common, each with the probability of 0.293. Moving on to the probability distribution graph, you can see the visual representation of the data. The bars indicate the probabilities for different sleeping hours. As mentioned, 4 and 5 hours have the highest probability. showing that they are the
Good day, Dr. Norshila. I'm Roshan. Today I would like to present about my calculation part. The purpose of a correlation coefficient is to measure the strength and direction of a linear relationship between two variables. It's a statistical tool used in many fields, including finance, medicine, and investing. We are calculating the Pearson correlation coefficient to see the relationship between sleeping hours and mathematics marks. This formula measures the strength and direction of the linear relationship between two variables. Firstly, calculate the mean of sleeping hours x bar and mathematics marks y bar. Subtract the mean of sleeping hours from each individual sleeping hour value. Subtract the mean of mathematics marks and from each individual mathematics marks. Multiply the differences from step 2 and step 3 for each pair of data points. Sum up all the product calculated in step 4. This gives us a numerator for the correlation coefficient. Furthermore, calculate the variance of sleeping hours and mathematics marks by summing the squared difference from their respective means. Take the square root of the variance of sleeping hours and mathematics marks to get their standard deviation. Multiply the standard deviations of sleeping hours and mathematics marks. This gives us the denominator for correlation coefficient. Finally, plug the values of numerator and the denominator calculated in the previous slide into the formula to get the final value of Pearson correlation coefficient.
For this part of presentation, I'm going to present about how we calculate the numerator for the correlation coefficient represented by R. This step is crucial when finding the strength and direction of the relationship between two variables. For the formula for the numerator is xi minus with x bar times by yi minus with x bar y bar. For the first pair of data points, we calculate 2 minus with 4.625 times by 33 minus with 39.7735 equals to 17.7852. X equals to x1 equals to 2 and y1 equals to 33. Value of specific data points, while 4.625 and 39.7735 are the means for the x and y data. After calculating for each data pair, we sum up all of the product. The total numerator is 537.514. After calculating the numerator for the correlation coefficient R, we now move to denominator. The denominator normalizes the numerator by accounting for the variability in both variables. Formula for variance of sleep hours is x1 xi minus with x bar square. For example, 2 minus with 4.625 square. Variations of math marks formula is yi minus with y bar square equals to 22.43848. Formula for variance of math marks is yi minus with y bar square is 33 minus by 39.7735 square is equals to 2243.848, and the square root for it is 747.378. The denominator for R combines these two standard deviations using the formula of variance of x times by variance of y equals to variance of x equals to 9.375 and variance of y is 2243.848 equals to 537.512. Finally, we calculate R by dividing the numerator by the denominator. Numerator is 537.514 and the denominator is 537.512 equals to 0.164. The confidence interval for mean mathematics marks is confidence interval equals y bar plus minus t s divided by square root n, whereas y bar is mean of mathematics marks, t equals to critical value of t distribution at 95% confidence, s is standard deviation of mathematics marks, and n is sample size. The mean value is 39.7735. Standard deviation value is 22.88. Sample size is 40. Critical value is from 3 distribution table with df equals to 39, t equals to 2.0227. Margin of error is t s divided by square root n is equals to 20227, and 22.88 divided by square root 40 equals to 7.347. Confidence interval equals to y bar plus minus margin of error equals to 39.7735 plus minus 7.347 equals to 32.43 and 46.98. These are the final results for the calculation. Pearson correlation coefficient R is 0.164 and the confidence interval 91% is 32.43 and 46.98. These are the tables that shows sleep hours vs arithmetic marks.
So, in conclusion, this project found a small positive correlation between the number of hours students sleep and their performance in mathematics tests, with a Bayesian correlation coefficient of 0.164. And this statement also can be proved that sleep has some impact on mathematical performance. And other than that, like study attitude, health, and stress level also might affect their performance also. Therefore, while sleep is important for learning, it should not be the only focus when trying to improve academic performance in mathematics.